Hello students, in this video I'll be explaining how to represent non-metal in a chemical equation, and I will also be listing chemical formulae of some important covalent compounds which you need to remember. This is because they cannot be derived directly from the periodic table. I'm assuming that by now you have already gone through the online module on how to name and write the formula of some common covalent compounds. So you don't need to be able to depict all the non-metals present in the periodic table in a chemical equation. There are only certain non-metals which are important from the point of view of an exam. This includes, of course, hydrogen, all the period 2 nonmetals, and all the nonmetals which are included in group 7. So let's see in the slide how to actually depict them in a chemical equation. So boron has to be depicted as a single atom, so just by its symbol. The same goes with carbon. However, in the case of nitrogen, oxygen, and hydrogen, these are depicted as diatomic molecules. What it means is that a single molecule of nitrogen has two nitrogen atoms which are chemically bonded, right? So nitrogen does not exist as nitrogen atom in nature. It rather exists as a nitrogen molecule which has two nitrogen atoms chemically combined. The same goes for oxygen, which has two oxygen atoms chemically combined, and the same goes for hydrogen, which has two hydrogen atoms chemically combined with each other. Additionally, all the group 7 nonmetals also exist as diatomic molecules. So if you had to write fluorine in a chemical equation, that will be written as F2. If you had to write chlorine in a chemical equation, it would be represented as Cl2. If you had to write bromine in a chemical equation, it would be represented as Br2. And if you had to write iodine in a chemical equation, it would be represented as I2. Do keep in mind that this 2, which is appearing in this subscript, is not the valency of the element. It's just depicting that it's a single molecule of the element which has two of them chemically combined with each other, and this is how it naturally exists. Now, there are some compounds which are known by their trivial names. A trivial name basically is a non-systematic form of nomenclature that has been used historically, and some of them are still very common. For example, water should have been scientifically named as dihydrogen monoxide, but none of us actually use that. We still use the term water. And the same goes for ammonia, which should have been called nitrogen trihydride, but we never use that. So please remember the chemical formulae and the name associated with these two. So let's attempt to put our understanding in application in these two instances. So for example, we have the first word equation, nitrogen plus hydrogen gives ammonia. So we know from our previous slide that nitrogen needs to be depicted as N2, and the same goes for hydrogen, that needs to be depicted as H2, and these two combine to form ammonia, which we know is the trivial name for NH3. Okay, let's now do the same for the second word equation. So we know that hydrogen needs to be depicted as H2, oxygen needs to be depicted as O2, and these combine to make water, which is H2O. Now, some of you might notice already that these equations are not balanced. So balancing of chemical equation will be discussed in a separate video. So in addition to these, are there some other chemical formulae which you need to remember? And the answer is yes. So these are some of the other substances whose chemical formula, along with the name, you should be able to remember. The first being methane, that has the chemical formula CH4. Please remember that methane is actually not a trivial name. It is an IUPAC name. But how do we get the name methane? That is under the domain of organic chemistry. So we'll discuss that towards the end of the semester. Then hydrochloric acid is HCl, sulfuric acid is H2SO4, and nitric acid is HNO3. So these are some of the chemical formulas along with the names that you should be able to remember. So let's have some other examples to put our knowledge into practice. So we have methane. We already know that methane is CH4 and it's combining with oxygen. So oxygen needs to be depicted as O2. Now, from your previous PBS online module, you should be able to write the formula of carbon dioxide, which is CO2, and it creates water, which is H2O. Again, notice that this is not a balanced chemical equation, but that's not the focus of this tutorial. So hopefully you'll be able to understand how we are able to put the formulas against the name of the reactants and products using our understanding from the previous slides. Let's do one last example. So water, which is H2O, combines with sulfur trioxide, which you should be able to write on your own, which is SO3, and it forms sulfuric acid, the formula of which is H2SO4. Okay, the formula of acids in particular will be very handy when we do the next topic, which is acid, bases, and salt. So I hope this video was useful for you to understand how to depict the non-metals in a chemical equation and which are the chemical formulae of covalent compounds you should be able to remember since they cannot be directly derived from the periodic table. Thank you so much.